So just a little intro for this session, and also it was just for facility operations. And then we had our own green build with US Green Building Council come to us in 2017 and say, well, we want to be zero waste also. And we didn't have a true for events, but having done zero waste conferences for almost 10, 15 years, I knew it could be done, and it was the same principles. And that is what I do love about US Green Building Council is we're a member organization, and what we're working on is driven by our members, and we want to meet those member needs. And so the same thing is happening with construction. We had our first project, Lend-Lease, that came to us several years ago. It was building a small hotel up on the Joint Base in Washington. And they're like, well, we want to do zero waste construction. And we're like, well, we haven't done that before, but here's our scorecard and our rating system. And they were amazing. And they were already halfway through their project, and they stepped it up and really did it. And now we have our first pre-certified event, which is WebCore in the Genesis Marina. So today I'm bringing together some experts in this area. And first of all is Timony Hood, and I think most of you know Timony as our zero waste queen with EPA, and she keeps pushing us and driving us and mostly just providing amazing resources so we can get our job done. So if you're not on her zero waste e-newsletter, make sure you reach out to her. And she's just been a true partner with us many years. She helped us facilitate a $5 million Department of Labor grant for CRA and Earth Resource Foundation and 3 colleges that helped educate thousands of people. And then after Timony, we're going to have Mr. Mike Gable. I had the privilege of attending his event at Construction Junction, and it was really fun, but more importantly, just taking deconstruction and reuse to a whole nother level. And he's going to talk about it more, but they engage architectural students to be part of that deconstruction and reconstruction. And that's what we need to go with this. We need to get into the colleges and into the trade and really retrain everybody. And then we're going to hear from one of our actual construction companies, Turner Construction. I actually met Mercy's boss, Joe Murphy, many years ago, but I've had the privilege of working with Mercy over the last year, and she is working with her entire team to train them on zero waste and really delving into what is broken in the deconstruction and construction economy, and how can Turner, with their amazing footprint, and leverage, help transform that. And then last but not least is Amanda Kaminsky. She's the founder and principal of Building Products Ecosystem. She was actually part of the project up in Washington with Lend-Lease. And Amanda just brings together amazing people from all different walks of life in the construction industry to help really close the loop and develop new markets. So with that, I'm going to hand it over to Timony Hood, and she's going to start presenting. Timony?
Go with it, yes. So I'm thrilled to be here with you today and with this amazing group and audience. This is one of my very favorite things to talk about. And this is the hierarchy, which some of you may not be familiar with. I added the solar panels on top since we've got a building related subject today, but source reduction and reuse for EPA is the highest and best use of materials. We just put out a national recycling strategy, but our very top political appointee, Carlton Waterhouse, just confirmed in an interview that source reduction and reducing waste remain EPA's top priority. And I'll share that quote in the chat with you. So there's nothing like looking at beautiful buildings, and this is one of them. This is the Chartwell School, which is near Monterey, California, and it was the first LEED Platinum school. And we kind of worked with the project team and awarded a small grant. I think it was about $35,000 for them to develop a design for deconstruction handbook. And this entire building was designed to be adaptable and then easy to take apart at the end of life. They've got fire station doors, and what you'll see on the inside, let's see, there it is that it's fire station doors, and then all of the kind of raceways and lighting, it's all exposed, so it's really easy to check out. So Brad Guy, who's a brilliant architect and the founder of the Building Materials Reuse Association, which is now Build Reuse, up with these ideas for nail-free paneling, because paneling, oftentimes the nails become very time-consuming to remove, and they also can damage the lumber. So I love this one on the top with the adhesive strips where they could just pour an antidote and the wall falls apart. But the system they ended up using, which is very efficient because you don't need many nails at all or screws, is this channelized system. And we used that handbook to develop a national, and at the end it became an international competition on designing buildings for deconstruction and adaptation. And we partnered up, like everyone's been saying, partnering is so key, with the American Institute of Architects and BMRA, which is now Build Reuse. And the architects and the students that participated said they'd never build the same way again. The building in the upper right here, it was built on pin foundations, which I think will become more and more common as we're needing to deal with sea level rise and the ability to move buildings. That architecture firm said after running their materials through the greenhouse gas emissions calculator, they'd never build another building the same. The one here on the bottom was a building in Seattle called the Pavilion in the Park, and it could be kind of flipped apart essentially and moved as units to reside in other areas. And they've taken it apart several times and moved the modules different places. All of that competition information is still online at lifecyclebuilding.org. So deconstruction, it can be kind of tricky. Like, what does it mean, design for deconstruction? And there's been a lot of great work recently with AIA, but also early on, King County and others developed design for deconstruction key principles. And a lot of it has to do with having easily accessible connections that can be taken apart and using safe materials that are high value and can be recycled. So this guidance link, I hope, will help you kind of find out more about design for deconstruction. And here's the fundamentals for those of you who might be new to this area of deconstruction. It's essentially dismantling a building. So a deconstruction site looks a lot like a construction site. It's primarily for reuse, but it also incorporates recycling and or composting if there are materials that can't be safely reused or damaged. Another thing to think about when we talk about deconstruction is that it depends, right, on the markets, on the materials in the building, what is going to be reusable. And so in many cases, at the very least, pulling out the high value materials and what they call cherry picking is absolutely appropriate. But sometimes we're seeing 90% plus diversion from deconstruction job sites. And this, of course, reduces the bringing in of new building materials. So here are some of the amazing benefits of deconstruction. It definitely conserves materials, and EA estimates that twice as much C&D material, construction and demolition materials, are generated each year than all of what we call the municipal solid waste. That's what's generated in our homes and offices and businesses. So huge quantities of materials. It makes a lot of sense because C&D is so heavy, right? It's heavy materials. But just the reality of kind of, we spend so much time talking about recycling and what goes in which bin, and we may be oftentimes missing entire buildings that are being thrown away. I think there's also very important work to be shared on the health impacts of demolition, because when homes and buildings are demolished, hazardous dust spreads for blocks, literally blocks. And that gets into people's homes, onto the ground, into the waterways. So kind of a very important. And deconstruction practitioners have told us that about half the time, even after asbestos has allegedly been removed, they find it under the cabinets, let's say, or inside a wall around pipes, and they're able to make sure it's safely managed. Whereas with demolition, it's not. It's kind of a common stat out there that deconstruction creates 6 times more jobs, and those jobs can transition into construction and green construction as well. And then I'm going to talk some more about the embodied carbon climate impacts. And lastly, kind of this local circular economy opportunity to provide low cost, local building materials. So embodied carbon is a very hot topic, and that means all of the energy and greenhouse gas emissions that went into making and transporting and assembling a building versus what you often hear related to climate change in buildings, the energy that the building actually consumes, the operational carbon. Well, as you know, green builders and architects have gotten really good at net zero energy buildings and also at incorporating renewable energy. So what's left is the embodied carbon. And the government's landlord, the Federal General Services Administration, is calling embodied carbon the next big sustainability opportunity. And just today, the White House issued an executive order on federal sustainability with a focus on embodied carbon. So expect to see a lot more from the federal government, and also many in the kind of green building and architectural world are really focused on these opportunities. So on the deconstruction front, I've been around a long time, and there was sort of a game-changing event that happened in 2016. And that was that Portland went out on their own, first in the country, and said, you know, no more you should deconstruct, you have to. And they passed a mandatory deconstruction ordinance. And a colleague of mine, Nicole Ty, who runs the Reuse Alliance, as well as a deconstruction company, she came to me and said, nobody knows about what Portland's doing. Let's host them to kind of come and share that. And we started the Bay Area Deconstruction Work Group, which meets quarterly. And since then, we've gone virtual. So everything's done online. We meet quarterly. And we have people joining us from all over the world. There's about 540 people on our distribution list. And it's just been amazing to see the interest and the policy development going on in this area. So expect to see a lot more deconstruction ordinances and policy passing. So here are just a few examples. In Palo Alto, they wanted to be the first, after they heard about what Portland did, to pass a mandatory residential and commercial deconstruction ordinance. This is right near San Francisco. And the same time, they passed a plastic foodware and a disposable foodware ordinance. And then they calculated the metric tons of carbon equivalent difference in the potential impact. And you can see the built environment really takes it away in terms of the climate impact. There are also some great tools out there that can help you convert what you're doing in terms of reducing waste and recycling building materials and other traditional recyclables. One is called US EPA's WARM model. And in the True Zero Waste Certification Program, you can get a point for running your materials through the WARM model. But you plug in your kind of the amount of tons going to recycling and landfilling and source reduction, and it gives you kind of the greenhouse gas emissions impacts. And then California built on this for something very practical, especially for reuse folks, is a wood reuse benefits calculator where you plug in a large table, a chair, the amount of lumber or hardwood flooring, and you get out the greenhouse gas impacts. So really valuable tools that keep on being improved. And I know that this is the day when we've got a lot of folks from the commercial business side joining us, and a great group with many folks from the Bay Area Deconstruction Work Group started up, involving tech companies, architecture firms, and building materials kind of management and owners coming together to talk about commercial reuse. They've got a pledge out, amazing resources on this site. It's called allforreuse.org. And next, I wanted to tie in a little more, not only to the embodied carbon in materials, but into the actual impacts of climate change and the climate crisis and how that might affect how we're thinking about buildings in the built environment. So this is an example from Florida that Brad Guy also worked on, where they had a home that hadn't been damaged, but was in a floodplain. And so FEMA was buying it out, essentially saying the people do not want to move back. They want to move somewhere else. So it was taken apart, and this is called panelized deconstruction. So they took a chunk of the roof down and then deconstructed it on the ground. And they built this brand new affordable housing that the owner just loves, or the person who's living there now, out of those materials. So it's actually taking an old building, making a new building, and right there locally. And kind of on the bigger picture, thinking about what this means all along the coast and in areas that are subject to flooding in terms of sea level rise, we actually have great potential to start thinking about what can we do to salvage those buildings that are in harm's way, because they're often not even damaged at all. They haven't been flooded. They're just starting to fall into the ocean or into the river. So this is an example 15 miles south of California with apartment complexes on a sea cliff that are starting to fall in, and they're all being demolished. And kind of the standard language that FEMA and California Coastal Commission use, that you will landfill all of that material. But what a tremendous waste, and something that needs to be, I think, looked at more closely. And I'd like to kind of close out showing you some beautiful examples of reuse. This is kind of what reuse looks like at scale. There was 300,000 board feet of lumber salvaged from an old warehouse that were used to make the Army Corps of Engineers headquarters building. And this is quite a while back, 2012. So this is not something that's a brand new initiative. So for all of you incredible leaders on zero waste, I just encourage you to keep the built environment and policies around reducing waste in the built environment in mind. This is one of the winners of the Life Cycle Building Challenge, where you can see, again, kind of the exposed assemblies and the beautiful structure that really melts into nature. Thanks so much, everyone. That's it for me.
Great, thanks, Tiffany. And we're bringing Mike Gable up next, and Mike can share his screen. There's the green arrow. We're going to save questions to the end, so please put them in the chat, and the speakers can answer them through the chat or at the end.
All right, is that up? Can people see it?
Not yet. So make sure you hit the green arrow, and then when it comes up, hit share.
All right, I'm not, okay.
So while Mike is putting that up, right after this session, we're going to have a short zero waste economy. There we are, Mike, and bring back our artists from this morning. So take it away, Mike.
Thank you, Stephanie. Good evening. At least it's evening where I am. The title of my section of this presentation is Reuse in the C&D Waste Stream, Turning Construction and Demolition Waste into Local Resources. My name is Mike Gable. I'm the Executive Director of Construction Junction. We're a reuse retail warehouse located in Pittsburgh, Pennsylvania. I'm also the board chair of Build Reuse. Tiffany referenced Build Reuse. We're a national membership organization that has other stores like Construction Junction involved, deconstruction contractors, municipal government folks who want to implement reuse and deconstruction ordinances, students, academics, preservationists, and architects. So anybody that's interested in reuse and deconstruction, they are invited to get involved with Build Reuse. And my screen is not going forward here. Let's see. Ah, there we go. So why do we need organizations like Build Reuse? And construction junction working on the local level. Well, we are living with the result of the impact of the linear economy on the built environment. We've obviously heard a lot about that today. The linear economy in the built environment has produced tremendous resource use. Our natural resources, we have tripled that use since 1970, and the projection is that we will double that use again by 2050. And if we stay right where we are in terms of what we are consuming on a resource basis today, by 2050, we will need another 1/2 to 3/4 of an Earth to meet that resource need. And the biggest rise in resource consumption during that time will be minerals, and including construction materials and metals. And this industry is already producing 30 to 35% of the global waste stream. So we need to make an adjustment, and we need to make an adjustment to the circular economy. And the concept of circular economy has been really exciting to me as someone who's been involved in the world of reuse for over 20 years, because the central tenet of the circular economy is to keep material in use for as long as possible. And we do that through salvaging, we do that through maintaining, we do that through repairing and remanufacturing. And sort of the bottom of that hierarchy, it's important, but the bottom of that hierarchy is recycling. But we've spent a lot of time building infrastructure around C&D recycling, but we haven't made comparable investments in C&D reuse. In fact, C&D reuse and building material reuse is kind of part of the informal economy, which is why I added this chart to kind of give folks an idea of what's really the difference when we talk about C&D recycling versus C&D reuse. And C&D recycling, we're trying to maximize weight. In reuse, we're trying to maximize value. And recycling C&D material is dealing with the really heavy stuff, the concrete, the asphalt, the materials and volume, whereas reuse is really focused on the building material components, doors, windows, plumbing fixtures, lighting, flooring, even down to office furniture, and filing cabinets and things like that. The energy expended for recycling is pretty much expended for material transformation, the grinding and the using that material in other construction materials. The energy expended in reuse is really the labor required to salvage and deconstruct, as Timony was showing you slides of, to keep materials intact so that they can be reused. The recycling industry is very centralized and mechanized. The reuse industry is very decentralized and labor intensive. There are about 300 material recovery facilities in the United States focused on recycling. There are between 1,000 and 1,500 facilities that are dedicated to building material reuse. We don't really know exactly what that number is. There's not a really great way to track the folks that are doing this work. That's a problem when we need to be quantifying this activity. The value, the global value of C&D recycling is over $7.4 billion. We don't really know what the value of the building material reuse industry is. We don't know what's the value of doors that are resold in the United States every year. We don't know the value of doors that we're missing. What value is going into the landfill? We don't have good data around that. I'm showing this slide to show you the difference. And we have really good data on how much concrete is landfilled versus how much concrete is actually reused and has another life as another part of the product. We know the big stuff. We just don't have good data on on what's happening in the building material reuse industry. And if we don't know the value of that industry, we can't advocate for it. It's difficult to raise funds for it. It's difficult to get ordinances passed. We really need to focus on getting value on this stream. And when we talk about the reuse opportunity, we're talking about that 25 to 30% of the C&D waste stream that's not concrete and asphalt. Again, plumbing fixtures, light fixtures, doors, windows, insulation, all of the kinds of materials that you will see at organizations like Construction Junction that are nonprofit reuse retailers that are dedicated to promoting the reuse of building materials. We're a nonprofit organization. We've been around for 22 years. We've got a 102,000 square foot facility and a $2 million operating budget. So we can tackle pretty big projects. The core programs that are part of our operation, the primary core is diversion of used and surplus building materials. We do that through offering a free pickup service. You can drop materials off at our facility. We're open 7 days a week. And we also have a deconstruction crew, which again, Timothy did a great job of showing you some examples of deconstruction. We fund over 80% of our budget through our public retail sales of donated building materials. We also have an expanded infrastructure for other reuse and recycling partnerships. We've got operations in our building that recycle bicycles, art supplies. We have a commercial door reuse business within our operation. We have a couple of job training partnerships. Because reuse is so labor intensive, we have a program with Goodwill Industries where folks with disabilities are managing all of our doors and banding all of our tile. We also have a partnership with another community organization that provides deconstruction labor for jobs where we need to ramp up. Those are bigger jobs than our standing 3-person crew can handle. And then we also have Project Re and a value-added shop. And I'm going to show you a couple pictures of Project Re at the end. So I'm going to wait for that one. Here's a little bit of eye candy from our store, some of the things that we get. What are the impacts of a store like Construction Junction? In 2019, we sold over $1.8 million of salvaged and reused building materials. Our employment opportunity fluctuates between 27 and 32 people. Those don't include our job trainees, which could be 10 to 12 people at a time. We had over almost 50,000 customer transactions with about 225,000 items sold. We processed over 6,000 donation receipts, 20,000 hours of paid training. We also have an inventory system for our organization, so we can track what comes into the building, who donated it, and what we sell. We don't track things by weight. We actually track things by item. So you can see some of the impacts of the materials, of how many things that we've actually kept out of the landfill through sales. You can see some of those numbers, over 75,000 doors, 128,000 light fixtures. And those numbers don't include the individual pieces of hardware, the 2x4s, the dimensional lumber that comes from deconstruction, and just the basic pieces of hardware. So how do we get all of that material? This is the most challenging part of what we do, is the process of receiving materials. And we try to work with local contractors and architects so that we can access large jobs, schools, churches. We're not just getting material from residential folks who are replacing a kitchen or remodeling a bathroom. We are really trying to do this at scale. And in order to do it at scale, we have to have what we do built into the process of how construction projects take place. I'm not going to go through all the details of how this works, but the three main components that we are that we are trying to persuade to do more reuse on construction projects. We work with the owners of buildings, we work with the architects, and we work with the demolition contractors. And really the inroads for the reuse message are the architects, because they're having the first interactions with owners. They're letting owners know that they can donate materials for tax deduction, that we have the opportunity for deconstruction, that we have a free pickup service, that we can come through and make material lists for the owners so that we can help them manage that material, so that we can help architects create specifications so that everybody on the job site knows that Construction Junction's coming onto the site. Here's when they're coming, here are the materials that they're taking. This is a really, really critical component of working on these larger scale projects. I'm not going to go through, again, the specific details, just want to let folks know that I've outlined the key challenges for owners in a lot of these projects, and what are the benefits for owners to be involved, key challenges for architects, and also how to make architects aware that there is the opportunity for Construction Junction to come and reuse materials, and work, and their role in making sure that this happens. Same things with key challenges for contractors, scheduling us being on the site, scheduling deconstruction, scheduling material pickups. Who's doing the work on the job? Is it going to be Construction Junction? We're not a union shop, so sometimes we've got to work with local unions to actually pull material, and then we come and pick that material up. So all of that has to be coordinated. We've been really successful doing that kind of coordination with the University of Pittsburgh, for example. So the last part of this that I want to talk about is the importance of innovation in the reuse retail world, the facilities that do building material reuse. One of the programs, one of our signature programs that Stephanie was also mentioning is Project Re. This project reuses materials, rebuilds communities, and restores lives. This project specifically works with architecture students on design build projects and exposes them to doing design and build work with salvaged and reused materials. This is the first project that our collaboration with Project Re completed. It's a community room. It's actually inside Construction Junction. The ceiling is made out of parts of church pews. We've got a chalkboard, a salvaged slate chalkboard wall in this facility. All the insulation was all salvaged. All the cladding on this building was all scraps of material interspersed with deconstructed lumber. So this is the kind of projects that really help people understand that you can design and build with reused materials in a way that can be indistinguishable from new materials. So I leave you with that piece of this inspirational project. Thank you.
Great, thank you so much, Mike. And you can put questions in the chat for Mike and he can answer them. Next, we have Mercy from Turner Construction. And I think, Mercy, you're calling in all the way from Madrid. So please welcome Mercy. And you can go ahead and share your screen. Mike, you might need to stop sharing.
How's that?
Great, and now Mercy can
Sorry
share
about
her screen. Terrific. Let's see, Mercy, I think you need to hit slideshow or full screen.
Oh, okay. There you go.
Fabulous.
Can you see my slides?
Yes, looks great.
Okay, perfect. Okay, so on today's agenda, I'll be talking about waste tracking at Turner Construction, some of the data highlights, waste management practices in different regions around the nation. To give you a little bit of background about Turner, we were founded in 1902. We have over 45 offices in Northern America with 10,000 employees, and we implement about 1,500 projects per year, ranging from stadiums, airports, hospitals, schools, from renovation to ground up, working with clients on the private and public sector. A fun fact about Turner is that for the last 14 years, we have ranked #1 green contractor per ENR, and this is the latest report on 2020. We really take sustainability practices to the heart, and one of the sustainability practices that we'll be talking about today is our waste management practices. So our waste tracking tool is called Turner Tracker, where basically all of the projects around the nation are required to input all of their data onto the system so that we can see how we're doing as a company. Through this website, we're able to input waste management for each project, where we input what the expectations are towards the haulers. And for instance, each hauler is required to input hauling tickets into the website, and a Turner representative gets the chance to either approve or reject them. From here, we also get the chance to convert tonnage to greenhouse gases so that we can understand the impact that we make as a company. And these calculations are done using the EPA WARM model. For the past 15 years, we have had the commitment to reduce 50% of the waste materials that goes into the landfill. Some of the data highlights that we have been able to discover through the use of tracking our waste data has been that 2 million tons of greenhouse gases have been saved. And to put it into perspective, that's as if we were to have stopped driving 435,000 cars for 1 year. In the last 2 years, we have also achieved 90% diversion rate and higher for 107 projects around the nation. We have also recycled 1.8 million tons of waste. That's as if we put the weight of 400 elephants, which has led us to achieve 71% diversion rate overall. Now, when we think of waste, we know that waste differs from region to region, from state to state, and even city to city. But we have noticed that waste can be dealt with, and we can achieve zero waste practices with the same practices, basically. So I'm going to walk you through different projects at Turner in different regions that have achieved really well with best practices. So I'll be starting with a project in Northern California, where we achieved 74% diversion rate by focusing on composting and recycling. So we decided that it was important for us to communicate with the trades on weekly reminders, where we specifically stated where we placed all of our trash bins in the launch areas, where we specifically noted with photos what could and could not go into each bin. At this project, we also implemented a pilot program where we decided that we wanted to reduce the amount of single-use water bottles that were going into the landfill. So we installed portable hydration stations, and we gave reusable water bottles to each of the workmen in the job site. By doing this initiative, we were able to save $78,000, which also related to carbon savings. We notice that these practices are important for us to create a culture of waste reduction that not only impacts the job site, but also workers are able to live with these new values that can be implemented either at their house or in other projects. Next region is in Cincinnati, Ohio, where the project was able to achieve 95% diversion rate. And this was done by focusing on recycling 100% of concrete and steel, as well as reusing pallets, wire spools, and dunnage. We also understand that it's important for us to minimize the amount of commingled waste that is contaminated. And one of the initiatives that we can prevent that is by separating municipal solid waste and construction and demolition waste. By doing these practices, we were able to save 4,700 metric tons of carbon dioxide. And that is as if we wouldn't have driven 1,000 cars for 1 year. Next region is a confidential data center in Ohio as well, where we achieved 95% diversion rate by source separating 7 materials, where it was easier just because we had enough space to do so. We were able to achieve these again by constantly communicating with our workforce and sharing multiple logistics maps of where exactly each of these dumpsters were located. We also were able to create a close relationship with the hauler and the sorting facility, where the Turner team visited the facilities and were able to learn what happened to the waste the moment he left the job site. We also saved $50,000 by closing the loop on the concrete that was coming out of the job site by crushing it on site, where when we finished crushing it, we used it for the foundation that went into the same building. We also wanted to close the loop on drywall, and we faced a little challenge because the closest facility that was found to Ohio was in Pennsylvania. So from Ohio to Pennsylvania, it's about 400 miles. And we were thinking, hey, is it really worth it for us to recycle if probably by driving it, we would emit more greenhouse gases? So I did a little study to find out what were the greenhouse gases emitted if we sent it to the landfill versus recycling, where to my surprise, we were able to find out that still recycling and sending the drywall 400 miles away from the job site emitted less greenhouses than sending it to the landfill that was only 28 miles away from the job site. Next project is in New York. And the reason to why I want to highlight this project is because, as we already know, downtown areas tend to be very congested. And one of the complaints that we hear often is that source separation can take a lot of space and that it's complicated. Well, this is an example that it could be possible. So what the project did was basically require each subcontractor to bring mini bins to separate their own material. These mini bins were strategically placed throughout the job site, where the 30-yard dumpsters were only brought into the job site to fill it in when the mini bins were already full. Then later we had the laborers dumping the mini bins into the 30-yard dumpster. This allowed us to strategically place the mini bins in other areas to allow for better space and to only have the 30-yard dumpsters when they were necessary. This allowed us to recycle 100% of concrete, drywall, ceiling tiles, cardboard, plastic, metal, and wood. The other project is in Florida, where they did an excellent job at communicating and training the workforce on the waste management practices. By training the workforce specifically on what was acceptable and not acceptable on each of the source separated bins. This allowed us to understand what were the haulers' needs so that we could, as a contractor, help them achieve better recycling rates, and as a return, us doing our commitment to reduce 50% of the waste that went into the landfill. The project was able to communicate these ideas by, again, displaying a logistics maps that specifically showcases where the dumpsters are located. And the key takeaways of all of these best practices as a contractor is to understand that waste can be managed differently across the country. But as it was mentioned before, these initiatives are basically the same. It is important for us to work as a team, constantly communicating with the haulers and understanding what their needs are, and minimizing the contamination that we send into the landfill to maximize recycling. And we can do the minimum by easily separating municipal solid waste and construction waste. And basically, this concludes my presentation.
Great, thank you, Mercy. And we'll bring up Amanda next. And what I appreciate about Turner and many of the companies we've heard from today is they're never satisfied. So they're always reaching higher and higher up the zero waste hierarchy and pushing themselves in their communities. So Amanda, the floor is yours.
Great, can you see my screen?
Yes, we can.
Okay, great. Well, thanks everybody. Thanks Mercy, Mike, and Timony. Two awesome presentations. I always learn a lot from all of you and the great work you're doing. So glad to be a co-presenter with you. So I'm going to talk a little bit about the collaboratives that we're focused on at Building Product Ecosystems. And the way we work is by really consistently challenging ourselves to look at the whole system within which a material and or product is harvested, manufactured, used, and then recycled or reused. And also the people that are affected oftentimes currently negatively, and how do we make that a more positive interaction with the making, use, and reuse of a product over time. So first, I'm going to talk about fundamental transparency that we utilize in starting to figure out how to optimize different material streams. And then going to talk about some of these initiatives that we focus on and specific materials. So when I talk about transparency, I'm talking about the ingredients that go into these materials and then the associated health that is tethered to those ingredients. And then also the climate and overall health, environmental health associated with these materials. And so we find this being really key to understanding how to reuse and just better optimize these materials. And in looking at environmental product declarations, I think everybody's getting a lot more familiar with embodied carbon and understanding what embodied carbon is in relation to operational carbon, which has been maybe a little bit more familiar to people over the years. I find this diagram from Carbon Leadership Forum to be really helpful on that front. And then through the Recycling Certification Institute, really getting to a place where we can trust the data that we get from our recycling facilities. A lot of times that's traditionally been much more artistic than scientific. And in order to really make improvements, it's extremely important to be able to trust that data and know that it's valid. And so we're asking for RCI certification from recycling facilities wherever possible. That's much more commonly available, like in areas like the Bay Area. In some areas like in New York City here, we have only 2 facilities within reasonable distance from a lot of our projects that are RCI certified. So we're hoping to increase the number of those facilities and with those certifications. So we also work with building owners to drive some of the changes that we want to see in our material supply chain and in reuse. But then in order to actually make these changes, we work a lot with manufacturers, construction management, our design teams, and everybody else that needs to be involved, from government folks to recycling facilities and a number of other team members. So with regard to deconstruction and reuse, I'm not going to spend a whole lot of time on this because I think this was well addressed by Mike and Timony. But I think what's kind of key here thematically is that deconstructing enables us to, first of all, reuse a lot more than we would be able to otherwise, but it also fosters better recycling rates down the line too for items that can't be reused. There we go. So also we find that when we reuse, we're certainly lowering the embodied carbon as exemplified through this statistic on wood. And we also know that we're improving on a number of other fronts. There's a lot of improvements that to be had through workforce development, just culturally a respect for the history of a place and the materiality of the vernacular of that place, reduce tipping fees on the economic side of things, and just savings to be had through the careful management of those resources. And a lot of this is just a logistics question. So how do we integrate reuse into design and build by looking at our project schedule early enough to ensure that we integrate it at the right milestones throughout the overall construction process, whether that be a remodel or a full building deconstruction and rebuild. And it's, again, it just comes down to careful planning. So we've been looking also at mapping out across the US in particular, where we have what our reuse ecosystem is looking like. Yarden Harari from CRTKL was doing this with a group of folks at Building Green as well. And so we joined forces, and we're working on establishing a map-in matrix that should be live and linkable to a lot of different sites, including on the Alpha Reuse site, hopefully on the Build Reuse site, and a number of other places in early 2022. So keep an eye out for that. And this is just a reference to a white paper that Google, Ellen MacArthur Foundation, and Building Product Ecosystems wrote at the end of 2019 and published on commercial deconstruction and reuse. So good resource for teams and government entities. So I'm going to talk a little bit about drywall source separation and closed loop recycling. In considering, in really looking at the whole system, as I was mentioning at the beginning, we understand that whenever we send drywall to landfill, it causes a real problem for the communities around those landfills in a lot of cases where you have anaerobic conditions and humid conditions, which is a lot of places around the US. You get hydrogen sulfide gas generation, and that is an asthmagen and can also cause other health issues. But it's something that a lot of times people don't know when they're making decisions on a construction site, but it's something that's really important to factor into the overall rubric for how we make decisions about where we send materials. So as a result of that, we've been driven to really look at increasing the capability for closed loop recycling in more places around the US. Mercy's totally right. It's a big challenge where you don't have a processor within a region. A lot of times, in some cases, drywall manufacturers will accept material back and do some processing themselves, but depending on that volume, that can overwhelm a manufacturing facility that is really, in business to manufacture and not to recycle. So, so that processing link is really key. And so we're looking a lot at how do we drive some of the improvements that we want to see with our manufacturing community and with the recycling community. And so we've written letters to voice the interest in source separating material from our job sites to make it easier for that recycling back into drywall, to reduce the contamination to happen. And so this is a picture from a drywall manufacturing facility out in California, getting together all the different components of the team that we needed in order to really make the logistics work. So speaking of logistics, this is a one-pager that we put together to broach how to do source separation on the floor by floor, taking just examples from a number of different projects over the years. And then in the loading dock, source separation via 30 yarders in some cases, and then via trucking, using anything from dedicated packer trucks to 30-yard or 20-yard roll-offs to box truck situations. And so that's been helpful for a lot of our teams. In addition, we've found that standardizing through ASTM can be very helpful for scaling a change in the system so that people know how to quality control it. So this is an example. This was published in 2020. Not a lot was happening in Q2, Q3 in construction in 2020, but and this was a few years in the making, but so it was a bright spot last year, getting this standard published. So last, I'm going to talk about replacing some proportion of cement and concrete with recycled glass. So kind of merging municipal solid waste and C&D in this solution set. And there's a lot of building owners that have been looking to optimize concrete for a number of different reasons, really looking at lower carbon concrete. Cement is the huge exacerbator of global warming potential in concrete. And as you can see on these diagrams here, though it's only between 10 and 15% of the mass of concrete, it's responsible for about 80% of the global warming potential of a concrete mix. And so, and I think we all know that it's has a huge impact overall in considering all the different impacts, CO2 impacts around the world. So frequently we're trying to replace that cement content with other byproducts. Traditionally, that's been fly ash and slag. Fly ash is diminishing, though we're harvesting fly ash from storage ponds. It's still diminishing in availability, and so that's needing to be replaced with other materials in many places. Same thing with slag. We have less and less steel and iron production in the U.S. That's having to come from further and further away. Prices are increasing for slag. So we do consistently have a steady glass supply, for better or for worse. A lot of times glass isn't getting recycled otherwise. And so when glass goes through a sorting facility, in a lot of cases, the smaller particles of glass, even if you want to recycle that back into bottles, the smaller particles can't be color sorted for that purpose. And so it can be synergistic with bottle glass recycling. But as you can see from this diagram, from Oregon DEQ and this really great resource that they just published, this waste impact calculator. In many cases, it can actually be more beneficial to recycle into pozzolan, like from the perspective of global warming potential. So we have needed to engage again with a number of different entities, our engineers, municipal recyclers, batching facilities. There's a lot of inertia in the concrete industry, and there should be. We have to be really careful with structural materials. And so, to make a change, we have to be very careful and do a lot of piloting and testing, which we've done a lot of over the last 10 years. This glass can come from bottle glass, but it can also come from window glass retrofits. So we started utilizing glass as a cement replacement with partners in a lot of precast materials like pavers and concrete masonry units. Moved to sidewalk. Montreal was a leader on this since 2011. They've poured 22 miles of sidewalk with glass cement replacement. In New York City, our DOT here has done pilots with this material. We've moved into structural material using glass as a cement replacement at 35% of the cement in the mix, which is decently high replacement, and then 40% in the building on the right. And so we, after about 3.5 or 4 years, we had enough data and industry buy-in to publish and get this standard approved, ASTM C1866, which has been really important for engineers to quality control this material. And so this is a great summary article on the right here too in Concrete International I can put the links to these in the chat then, for being able to reuse glass in this end use. These are bridges that were just poured, just finished recently up in Montreal with glass cement replacement. And it also helps to mitigate urban heat island effect because it's lighter in color than standard concrete. This just shows the global warming potential reduction of 42% when you replace 50% of a concrete mix of cement with glass. So just to wrap up here, this just shows some pictures of implementation at scale. There's a full-scale processing facility. By processing, I mean cleaning and grinding of municipal recycled glass to be ready for use in concrete. Some of the projects it's been used on, and that's it.
Great. Thanks so much, Amanda. What I really appreciate, Amanda, is that she takes a very scientific, factual approach. So in bringing all these stakeholders together, and like she says, we're talking about integrity in our roads and buildings and everything. So it's really where the middle meets the road or the car meets the road. So thank you so much.